Hey students, here's the spiral review for Spiral 1. We're starting off with functions and quadratics, and we're going to start off with problem 1 where we're asked to find f of g of 3. What this means is that we're going to find g of 3, which is going to be, instead of x to the third plus 1, 3 to the third plus 1, which is 28. And then from there we're going to find f of 28. So instead of 3 times x minus 1, it's going to be 3 times 28 minus 1. That's going to be 60, 84. So then we got 83. For number 2, we've got to find f of x plus h minus f of x. And I've done the really mean thing to you of giving you an x cubed, an x squared, and an x to plug into. So just to kind of deal with this part first, we've got to plug x plus h in. So x plus h to the third power. And then we got 2, and then instead of x, x plus h to the second power, minus 5, x plus h, and then plus 4. I'm going to color code this. This is just for this first part, and then we're going to have to minus the original function afterwards. So let's go piece by piece. So I would have to write this as x plus h times x plus h times x plus h. And when I multiply that out, it's going to be x to the third plus 3x squared h plus 3x h squared plus h to the third. For the next one, I'm going to have x plus h times x plus h, and then multiply that by 2. That would end up giving us 2x squared plus 4xh, and then plus 2h squared. We'd have our next one, minus 5x minus 5h. And then I'm trying to find a different color. And then just the plus 4. Again, that is just doing the f of x plus h part. I'm going to look to see if there's anything that are some like terms, and I'm not seeing any. So that's literally all that we have there. Okay, so from this, I've got to subtract the original, which is x cubed plus 2x squared minus 5x and plus 4. I'd like to notice that I've got an x cubed minus an x cubed. Those are going to cancel out. I've got a 2x squared minus a 2x squared. Those are going to cancel out. I've got a minus 5x and a minus 5x. Those are going to cancel out. And I've got a plus 4 and a minus plus 4. Those are going to cancel out. That leaves us with everything that's left. And if I were to take a look at that, that's going to be 3x squared h plus 3x h squared plus h to the third plus 4xh plus 2h squared minus 5h. A really nasty problem algebraically. But once you get through that, that's the end of the problem. All right, next up, we got to do some factoring. Here I'm going to try a times c is going to be negative 42. So I'm trying to find things that multiply to negative 42 and add up to negative 11. All right, that's going to end up being, let's try some, I don't know. Let's go with negative 14 and positive 3. So we got 6x squared minus 14x plus 3x minus 7. And that's going to be equal to 0, but we'll deal with that in a minute. For the first two, I can take a 2x out, and I'm left with a 3x and a minus 7. And for the next two, I can take a 1 out, and I'm left with a 3x minus 7. I've got 3x minus 7 times 2x plus 1. That's equal to 0, which means 3x minus 7 is equal to 0, or x is positive 7/3. And then we got 2x plus 1 is equal to 0, which is x equals negative 1/2. For the next one, this is one that we have to think about as x squared squared plus 4 of those x squareds plus 4. So we can do the same type of factoring here, where we have an a times c is 4, and a b is going to be 4 as well. That's going to be 2 and 2. So we have x squared squared plus 2x squared plus 2x squared plus 4. From the first two, I can take an x squared out, and I'm left with x squared plus 2. For the second two, I can take a 2 out, and I'm left with x squared plus 2. That gives me x squared plus 2 for what they have in common, and a leftover of x squared plus 2. If that's equal to 0, we're going to have both of these be the same, which is x squared is equal to negative 2, and x is equal to plus or minus the square root of 2i. In this class, we're dealing with all real numbers with the possible exception of this problem. Next up, we got some trig stuff. So we've got to solve this problem, and we're looking for the domain from 0 to 2 pi, not including 2 pi. So we've got cosecant squared going on here. I don't like that being negative, so I'm going to move that to the other side. So cosecant squared of theta, and I'm going to add 7 to the other side to get 4. I take the square root of both sides. That gives me cosecant theta is equal to 2, and cosecant theta is equal to negative 2. Because this is the reciprocal of sine, I'm going to rewrite this as sine of theta. I'm going to flip my 2 to get 1/2. And on the other side, sine of theta is equal to negative 1/2, because that's going to flip that over. All right, so we're looking for the signs that are 1/2. Those are going to be my pi over 6's. We got both the plus and the minus, so we're going to use all 4 of these. That's going to be pi over 6, 5 pi over 6, those are my 2 positive ones, 7 pi over 6, and 11 pi over 6. Those are the things that have a height of 1/2 or negative 1/2. For the next one, I have one that looks really messy, but let's get everything onto the same side and see what happens. First thing I notice, I've got a 3 tangent of theta on both sides, so those will end up reducing to nothing. And I already have 0 equals this stuff, so let's just kind of go with that. I'm going to take a sine of theta out on this side, because that's in both of these pieces. I'm going to factor it. And when I do that, I'm left with the negative square root of 3, not a fraction. And that's going to be plus 3. My sign goes away, and I've got tangent of theta. Cool. So for sine theta is equal to 0, that's going to give me some stuff. And then my other equation, negative square root 3 plus 3 tangent of theta is equal to 0. Sine theta is equal to 0. That's going to be here and here, because we're talking about the y values being 0. So we're going to have theta is equal to 0, pi, and 2 pi. But as we commented earlier, 2 pi is not included, so I'm not going to include that point. You would probably not lose any points if you included that. As long as you had your other 2, you'd be fine. For the other one, I'm going to move root 3 to the other side. I've got 3 tangent of theta is equal to root 3. Divide both by 3. Tangent of theta is equal to root 3 over 3. Okay, for tangent, I've got 2 possibilities for that, and I just kind of need to figure out which one's which. First thing is that I know that this is either going to be first or fourth quadrant, because we have positive, positive, and negative, negative. Those divide to get us positive values. The second thing is that this is either going to be a pi over 6 or a pi over 3, and I never remember which one, so I have to kind of think about that. The coordinates for pi over 3 would be 1/2 comma root 3 over 2, and the coordinates for pi over 6 are going to be root 3 over 2 comma 1/2. If we're talking about y divided by x, for tangent of pi over 3, that would be root 3 over 2, divide by 1/2 the y over the x. That equals root 3. Okay, that's not what I'm looking for here. I'm looking for root 3 over 3. Just to double check, tangent of pi over 6 is going to be 1/2 divide by root 3 over 2. That ends up being flipped, and you've got 1/2 times 2 over root 3 my 2's cancel out, so I'm accidentally hitting the plus button a bunch of times. I'm left with 1 over root 3. I know based on rationalizing stuff that I can make that equal to root 3 over 3. So therefore, we're dealing with the pi over 6 family. Again, we're dealing with just the first and the first and third quadrants. So that's going to be pi over 6. And here we've got pi over 6. We got 5 pi over 6. This one is 7 pi over 6. I know. Next up, we've got some logarithms. So we've got to do some work here. This is non-calculator active. So we've got to take a look at what's going on here. We're going to convert this to exponential form, and we've got 5 to some power is equal to 625. I would literally just go like this. 5 to the 1 is 5. 5 squared is 25. 5 to the third, I'm going to multiply that by 5, is 125. 5 to the fourth is that times 5, which is 625. So that exponent would be the 4. That means that log base 5 of 625 is equal to 4. That's the type of work you need to show to get credit for that. You don't need to necessarily do all of that out, but I need to see some of that thinking. All right, properties of logarithms. First thing I'm going to do is to reduce that, and I'm going to rewrite this as log base 10 of x to the third y to the fourth over z to the fourth. Cool. Now we're going to have, I'm just going to do this in 2 pieces because I know that some of us are struggling with this a lot. Things on top I'm going to add together, so that's log of x to the third plus log of y to the fourth. Things in the bottom I'm going to subtract, minus log of z to the fourth. Now I'm going to use my power of a power rule and bring all of these exponents down front. So you've got 3 log base 10 of x plus 4 log base 10 of y minus 4 log base 10 of z. And the next one we are solving. Since this is not calculator active, you don't really have to worry about not doing the exact answer, but I'm going to minus 3 from both sides. 5 to the 2x is equal to 7. And if I convert this to log form, it's going to be log base 5 of 7 is equal to 2x. Dividing by 2, we get log base 5 of 7 divided by 2 is equal to x. And the next one, I'm going to convert this immediately because we have a log by itself. So 3 to the fourth is equal to 2x plus 3. That's 81. 2x plus 3 minus 1 to both sides gives me 78 is 2x. 39 is x. And then finally, we've got some limit stuff. This is the first time that we saw this, so this is going to be feedback. I want to take a look at each of these things and see what happens. So we've got the limit as x approaches -4 from the right side. So here's my -4. Coming in from the right side, we're shooting down this way. That's going to be negative infinity. From the left side, we're coming in here and we're shooting up that way. That's going to be infinity. The limit as x approaches infinity, so we're going this way. That's going to have a height of 5. And as we approach negative infinity, that's going to have a height of 5 as well. Looking at the statements here, we've got to decide what is true and what is not. The limit as x approaches 2 exists. For that, the limit as x approaches 2 from the left of f of x must be the same as the limit as x approaches 2 from the right of f of x. That's a really important thing for you to write if you're answering this question on a spiral, to make sure that you get credit for your thinking. All right, so as x approaches 2, on both sides, I have a height of 2. So that's equal to 2, and we are okay. Okay, same thing from the limit as x approaches 3. From both sides, we've got a height of 5. For the limit as x approaches 4. On one side, we've got 2, so I'm going to say the limit as x approaches 4 from the left of f of x is 2. But on the other side, we've got a height of 4. The limit as x approaches 4 from the right side of f of x is 4. Because of that, that is not a true statement. Our limit can't exist if we have different numbers on both sides. And then just to kind of keep going, at 5 from both sides, we approach a height of 6. And we have this new idea of continuity. We can use our pre-calc understanding if we don't have any jumps or holes or gaps there. So that is a true statement as well.